Alright guys, so we're gonna be learning, you're gonna be watching a movie, a little class on domain and range. Okay? So domain is a set of ordered pairs X and Y. The domain is the set of all X ordered systems. So domain would be X, and we talked about that today. Now your range is the ordered pairs X and Y. The range is the set for all the Y coordinates. Remember my little trick. X comes before Y in the alphabet. Therefore, domain comes before range. D comes before Y in the alphabet. All right. So the set of ordered pairs may be a limited number of points. Given the following set of ordered pairs, find the domain and range. So I'm going to go ahead and I'm going to take off my x's first. So my domain would be 2, -1, 2, and 0. And my range would be 3, 0, -5, and -1. So again, the range is -1, 0, and 2. The range is -5 and 3, 0. And notice that we do not have to write the number more than once. So if the number occurs more than once, we do not need to list it more than once. The set of ordered pairs may be an infinite number of options described by a graph. Given the following graph, find the domain and find the range. So for example, for the domain, I'm going to go ahead. Egypt, another time for my big moment. Sorry about that. Okay, so for the domain, I'm going to have to take a look at my X. And I like to do this in highlighters or with a coloring pencil. That's your X. And then for the range, you got to take a look at your Y. Now notice that I did color all my X, but I didn't do it with the Y-axis because this graph is now going to the negatives for the Y values. So for example, for the domain, it's all real numbers because this graph keeps extending and extending and extending, and the more that it extends, the wider that you will get. See how wider it is at the top than it is at the bottom? So it keeps extending. So all the real numbers, all positive and all negatives, even all integers, those are the integers, but also rational numbers as well, because you have fractions. Okay? But the domain has to be greater than 0, because this graph starts, for the range, I'm sorry, not domain, but the range starts on 0 and then it goes all the way up to infinity, which means the values of y need to be greater than or equal to 0. So the set of ordered pairs may be an infinite number of points described by an algebraic expression. Given the following function, find the domain and the range. So for example, over here, f of x equals square root of x minus 5. So remember, yesterday on the video it said that y equals square root of x minus 5. This is the same thing. Now you can do square roots of positive numbers, but you cannot do square root of negative numbers. The opposite of squaring a number would be x squared. Okay? And any number squared would always be positive. For example, negative 2 to the square equals 4. So because of this, square roots can also be positive. So I'm going to show you what I mean by this. So for example, let's say I want to do the square root of 225. So I do second x squared, because the square root is on top of that, 225. And I close the parentheses and I hit equal, and that will be 15, because 15 squared equals 225. But what if I want to do the square root of negative 225? What will the calculator tell me? Now remember, any number square, it's always positive. So this is what it will happen every time you try to do a square root of a negative number. It will tell you that it's a non-real answer, and then it will tell you that you have an error. And that's correct, because any number squared will be positive. So for example, if I want to do negative 2 squared, that will be 4. Now that is completely different than doing this. That would be the opposite of 2 squared. That's what that negative means over there. All right, so knowing this, what would the domain be? The biggest number that I can substitute for x, remember, what's inside the square root cannot be negative. So the biggest number that I can substitute over here would be 1. 1 number minus 5 would equal 0, because 0 is the smallest non-negative number. Would be 5. Very good. So for my domain, x has to be greater than or equal to 5, because if I plug in that 5, it would be 5 minus 5, which equals square root of 0, and that would be 0. Well, what happens to my range? Has to be bigger than what? Than 0. Now, I'm going to show you another way of being able to do this, and it's a lot easier, okay? So for this, we're going to go ahead and we're going to get our calculator. Now, once you have your calculator up, we're going to go to y equal to, and we're going to graph the function. And the function says that it was square root of x minus 5. And then I'm going to graph it. I'm going to go ahead, and I notice that my graph starts right here. I'm going to change my window, and I'm going to put an x maximum of 0. That means an x minimum of 0, and an x maximum, let's just do 50. And then I also noticed that when I graphed it,
there was nothing on the y negatives. I'm going to keep it like it is just so that I can see, but there it is. Now, where does that number start? We already said, and you can actually zoom in to see it. That would be 1, 2, 3, 4, and 5. So my x has to be bigger than 5, and my y has to be bigger than y because than 0 because there's nothing on the negative for that graph. Okay? So for me, the easiest way to do this is to go ahead and go to the graph and see what I can come up with the graph, come up with the domain and the range from the graph. So find the domain and range of the following sets of ordered pairs. Now this one is easy. Go ahead and take your x's. Remember, if they repeat, you don't have to write them twice. So my domain would be
-8, -3, 3, 0, and 7. And my range would be -5, -1, that should be a -2, and then a 7 that I will not have to write twice. Now, this is easy to name the domain and range. Now, let's go ahead and take a look at this. Remember, for my domain, I'm going to look at my x. I like to do this with a highlighter and coloring pencil. It starts with 3. So x needs to be greater than or equal to 3. But my range, remember, as this extends, it gets what? Wider and wider. So my range would be all numbers. As it just gets bigger and bigger and bigger and bigger as it keeps extending. Alright, so for this one I will definitely go to the calculator to do this, okay?
okay. Now for this, remember f of x is the same thing as saying y equals to.
So in here it would be that would be the same thing as y equals 3x squared minus 4.
So after that, I would most definitely go to the calculator. Mine is already off, so I'm going to turn it on and I'm going to go ahead and clear it. Hopefully you remember it's second plus 7, 1, and 2. Now I'm going to go to my y equal to, and I'm going to write that function down. 3x squared minus 4, and now I'm graphing. All right, so that's obviously, it's called a parabola, to you going up. So I notice that on x, remember, as that parabola keeps growing and growing, it keeps extending. So my domain will be all the real numbers. But my range obviously starts right there. So I need to figure out what number would that be. So I'm going to assume, I'm not going to deal with the x's. I'm going to change my minimum for the y, because those were the negative numbers. I'm going to do -5, and then I'm going to graph it again and see what happens. Oh my God, that's beautiful. That'll be 1, 2, 3. I believe it's -4. So for that one, The domain would be all real numbers, but the range has to be greater than or equal to -4. All right, so let's go ahead and graph this one too. I'm going to go ahead and I'm going to clear the calculator once more. Second plus 7, 1, and 2. I'm going to go to y equal to, and I'm going to say 2 divided by x. Now, if you know anything about fractions, you will know that you cannot have a 0 as a denominator. There's no such thing as 2 slices of pizza when that is a 0 when there's no pizza. Okay? So, I'm going to go ahead and I'm going to graph it. And it looks like it's first quadrant and third quadrant. And for my x, looks like it's everything except for what? 0. And then for my y, about the same. So let's go ahead and see. The domain would be x is different to 0 because it's everything except for 0. And the range would be everything but 0. See how it does not touch the 0 either on x or y. All right. Let's go ahead and do the next one. For this one, I'm going to have to go and I'm going to have to solve for y first so that I can graph it, okay? So, to solve for y, I'm going to have to say minus x squared minus x squared would be 0. So y squared equals negative x squared plus 4. Or you can write it as 4 minus x squared. It really doesn't matter. It's the same thing. I just put the negative with the x and the positive. Now to get y, the opposite of square root of a number would be square root. So y equals square root of negative x squared plus. So let's go ahead and figure out what the range and the domain of the function are. So we're going to go to y equal to, and we're going to write down second square root negative x squared plus 4. And then I'm going to graph it. And there it is. Looks like a little happy face. So I'm going to zoom in and see my window. I'm going to change it to -5 and 5. My minimums and maximums. And I'm going to graph it again. There you go. So it looks like it goes from -2 to +2, and on the range, on the domain, I'm sorry. And on the range, it looks like it goes to 2, +2. There's nothing on the negatives right here. So let's see what the domain is. The domain has to be, again, between -2 and +2. That's why that is there. And the range is from 0. This is wrong. From 0 has to be, let me fix this. do the graph. Let's see the graph. Y has to be greater or equal to 0, but less than or equal to 2. It's positive 2. Let's see it again. There you go. From 0, less than or equal to 2, greater than. There you go. Okay, so let's go ahead and do that. Let's go to the calculator and write it exactly like we see it. You don't need to have parentheses. We don't need to distribute or anything. So that will be 3 parentheses x minus 1. Gotta go back. X minus 1 plus 2. And let's graph it. Oh, that's a straight line, which means on x, all real numbers because that line keeps extending, and on y, all real numbers because that y keeps extending. So there's your domain and your range. And for the last one, let's go ahead and do it. Y equals 2, and I'm going to clear it, and I'm going to write down square root of x. Now remember, square roots cannot be negative numbers. So has to be greater than 0 on your domain and greater than 0 on your range. It can be equal to as well. All right? So tomorrow we're going to practice a little bit more about this because I know this is a little bit more challenging. Hopefully this video will get you started moving in the right direction. If you need to see it again, you go right ahead and you go for it.